Let's consider the rules that we need to follow when you are writing electron configurations and orbital diagrams. The first rule is the Pauli exclusion principle. It says that no two electrons in the same atom can have the same 4 quantum numbers, which means that the electrons in an orbital which is defined by the first 3 quantum numbers, must have opposite spins so that at least their 4th quantum number is different. Here we have the 2 electrons of helium. They have the first 3 quantum numbers the same, but the 4th one, the spin quantum numbers, are different. This actually is the principle that an orbital can hold a maximum of 2 electrons. This is what you need to remember. And those 2 electrons must have opposite spins. The second rule you need to follow is that you have to get the ground state electron configuration for an atom, meaning the lowest energy possible electron configuration, which means that you need to start filling the lowest energy orbitals first. For lithium with 3 electrons, the atomic number 3, 2 electrons will be in the s subshell, 1 will be in the s subshell of the second principal level. For beryllium with 4 electrons, there will be 2 electrons in the 1s subshell and 2 in the 2s subshell. For beryllium, atomic number 5 with 5 electrons, electron configuration will have the first 2 electrons in the 1s subshell, 2 more in the 2s subshell, and 1 electron in the 2p subshell, which shows as 1s2, 2s2, 2p1. Remember, the superscripts are the number of electrons in those orbitals. And you see actually how an orbital diagram gives more detailed information. When you talk about the electrons in the second level p subshell for boron, the single electron is unknown as in which p orbital it's present. But when you look at the orbital diagram, we show it in a specific p orbital. The last rule, called the Hund's rule, becomes important when you are filling the electrons in an orbital diagram. You need to put 1 electron in each orbital before pairing them to give the lowest energy arrangement of electrons. For example, carbon has a total of 6 electrons. The 2 electrons go into the s subshell, first 1s subshell. The 2 go to the 2s subshell. Now we got 2 more to put to fill to 6. They will go to the p subshells, 2p2. However, they go as single electrons with the same spin into 2 different p orbitals. If a third electron was to put, for example, for the 3 electrons in the 2p subshells of nitrogen, those 3 electrons would be put one at a time with the same spin without pairing. When it comes to oxygen, now you got 4 electrons in the 2p subshells. The way they are filled is 1 in each with the same spin, and then the 4th one will go paired with one of the single electrons. For fluorine, it's 7 electrons total, and 9 electrons total, but 5 of them being the 2p subshell, will be placed one by one before pairing. Only when you run out of orbitals you start pairing. And neons 6 2p electrons, 6 electrons in its 2p subshell, will be placed one by one. 1, 2, 3, with the same spin in different orbitals, and then pair them up to have completely filled p orbitals. So based on that order of orbitals, how do you write electron configuration of atoms? Let's take calcium for an example, with an atomic number of 20, which means that it has 20 electrons. We're going to put 20 electrons in our configuration. We have to start with the lowest energy orbital, which is the 1s orbital. The maximum number of electrons the s orbital can take is 2. So therefore we say 1s2. Then we move on to the second shell, because the first shell has only 1s. So second shell starts with the s, which can take a maximum of 2. Next, we got 2p orbitals, and there are 3p orbitals if you remember. Therefore, a maximum of 6 electrons are allowed. So far we put 2 plus 2 plus 6, 10 electrons. We need to put 10 more. After 2p, we have 3s in order. An s orbital, as any s orbital, will take maximum of 2 electrons. Then we got 3p, 6, which made a total of 18. We need 2 more. And the next in order is 4s2, and that is also full. Now, not necessarily the ending orbitals will be full, but in this case they are full. So how do you write the orbital diagram? You need to put these orbitals one by one. We show them by boxes shown here. And the way to put electrons is as up and down arrows. If you remember the order, 1, 2, 3, 4. And then when it comes to the 2p, pay attention to the way that I'm putting them in. Again, 1, 2, 3. One in each before pairing, and then pair them up. When it's the s orbital, since there's only one, you can just directly pair them. But when it's the orbitals that have the same energy being filled, put one at a time before pairing them. Now, you can also use a noble gas shortcut. If you look at the electron configuration of calcium, up to a point, up to this point, it is a full shell configuration of the noble gas argon. So you can show that in square brackets as argon in square brackets to indicate all that configuration, and you just write the rest of it, and you would get the noble gas shortcut electron configuration.